Now let us discuss about internal energy. I already gave you an hint that internal energy means is due to the molecular motion. So first we will discuss about one component of internal energy, that is the sensible energy. So let us see what it is. This is one component of the internal energy. So sensible energy is due to the first thing is the molecular translation, because the molecules moves in x direction, y direction is the direction, etc. Because of this translational velocity, it possesses an energy, kinetic energy. This molecule possesses a kinetic energy, and this is called molecular translation energy. Then you have the molecular rotation. These molecules will have a rotational motion. On account of this rotational motion, it will have a rotational energy, another internal energy. And then you have the electron spin. See, these atoms or molecules have electrons, and these electrons spin in its own axis, and due to this electron spin, it has got an internal energy. Okay. And then you have the molecular vibration, that is the because these molecules vibrate along its axis, and because of this vibration, it has got an energy. Okay, just like a spring, it will vibrate. And you have the here you have the electron spin. Now you have the electron translation, it also moves. So because of that, it has got an energy, that is called electron translational energy. And then you have the electron spinning. Okay, so not electron spinning, this is the nuclear spin. Because of this, inside the nucleus, this nuclear spin, it has got an energy. So all these six energies constitutes the sensible energy, and sensible energy is just one component of the internal energy. It has got another component like nuclear energy and latent heat. So we will see that in next slide. So here we have discussed about all the sensible energy, and also there is a latent energy. So what do you mean by latent energy? See, latent energy is because when there is a change in phase, that means a liquid evaporate to vapor phase, so that means it absorbs a energy. That is the latent heat. So when the water vapor condenses, it releases energy. What Okay, when it becomes water, it releases, that is called the latent energy. That is also a part of the internal energy of the matter system. So then you have the chemical energy. Okay, so so that means during a chemical reaction, energy can be liberated or absorbed. So it has got a chemical energy. And then you have the nuclear energy. So these are the three different types of energy. The nuclear energy, it maybe is the energy released due to nuclear fission or fusion that we do not usually encounter during thermodynamic problems. Only in a nuclear physics only we usually see that. So mainly internal energy, we mainly deal with the sensible and latent energy, and to some extent we will use chemical energy also. So this is all about internal energy or the microscopic energy. So here microscopic energy is mainly concerned with the molecules. So you have the sensible energy, which includes this electron spin, electron molecular translation, vibration, rotation, electron translation, etc., nuclear spin, etc. All these comes under sensible energy. It is called sensible energy because of a reason. The reason is that because we feel the temperature of the system because of this sensible energy. Okay, we feel the temperature is increased due to the increase in sensible energy. So if that means if you supply heat to a system, that means the sensible energy of the system increases. You can feel that as the temperature increase. Okay. So this is now let us see what is the difference between microscopic and microscopic energy. So this figure speaks volumes about the difference between microscopic and macroscopic energy. Now, see, you can see that here this is a dam in which there is water is stored, and there is a paddle wheel at the downstream here. okay, the downstream here, and also you have kept a paddle wheel here also inside the dam. You can observe that this paddle wheel at the downstream easily rotates because of this motion of these water molecules. Because the water molecules here possess macroscopic kinetic energy, because all these water molecules coming out, it has got this macroscopic kinetic energy. Okay, and this can easily, because since the macroscopic kinetic energy are all in the same direction, it can easily rotate this paddle wheel. Okay, but let us look at this paddle wheel here. See, this paddle wheel does not rotate because here also the water molecules has got energy, but it has got internal energy. That means these molecules are moving. So because of that, it has got energy. But these molecules move in random direction. It is not moving in a specific direction. Okay, only at the down it becomes it comes under a straight line. Comes in a straight line. Otherwise, inside the molecules move randomly, and because of this random motion, it is not able to rotate this paddle wheel. Okay, so this is the difference between macroscopic and microscopic energy. In see, one thing you can easily notice is here that macroscopic energy is much more useful. Macroscopic energy is much more useful and can be utilized to run any device, but microscopic energy you cannot easily make use of this microscopic energy. You can make use of this macroscopic energy 100% utilization, but microscopic energy is not. So we will study that in that later. So this is all about energy. What do you mean by internal energy and what do you mean by macroscopic energy?